Hello everyone, and welcome to our channel mootechie. It's great to have you back. For our dairy technologists and students, this is class 4 in our series on dairy engineering, continuing directly from our previous discussion. Today we're diving deeper into Unit 4, focusing on the machinery that makes modern packaging possible. Let's begin with an overview of aseptic packaging systems. These systems are crucial for maintaining sterility and are categorized into three main types: cup and bottle systems, sachet and pouch systems, and carton systems. Now let's explore cup and bottle systems in more detail. These systems offer several advantages. They have a low risk of breakage and are resistant to high temperatures. The packaging can be designed to be see-through or to provide complete light protection. They are manufactured in many different shapes. Most importantly, for aseptic applications, they remain sterile during the filling process. These containers are typically made of materials like PP, which is polypropylene, or PE, polyethylene. For multiple uses, a material called polycarbonate, also known by the brand name Lexan, is often used. Moving on, we'll look at the manufacture of plastic bottles. There are two primary methods: injection blow molding and extrusion blow molding. First, let's understand injection blow molding. This process involves several key steps. It starts with preform injection, where a test tube-like preform is created. Next, a stretching force is applied to the preform. Then, compressed air is blown into it to expand it into the final bottle shape within a mold. Finally, the finished product is ejected. The machine uses cooling water to solidify the plastic. An injection blow molding machine is designed to work with specific materials. Commonly used plastics include PET, which is polyethylene terephthalate, and HDPE, or high-density polyethylene. Next, we explore the second method, extrusion blow molding. In this process, heated plastic is first extruded into a hollow tube called a parison. Then a mold closes around the parison, gripping it in place. Compressed air is then blown into the parison, causing it to inflate and take the shape of the mold. Once the parison has filled the mold, the product is trimmed and removed. The finished product is then ready for the next stage of production. Now, let's compare the two methods. Injection blow molding is typically used for manufacturing more solid parts and components. It works well with materials like polycarbonate or PC and polyethylene or PE. On the other hand, extrusion blow molding is ideal for creating hollow objects like bottles and containers. It commonly uses materials such as HDPE, PP, which is polypropylene, and PET. To see this in a real-world context, let's look at an example of an aseptic bottle system. The Combi Predis FMa 3010K from LSDH France is a low-output aseptic solution. It uses a dry preform decontamination process and is designed for packaging UHT milk and fruit juices. This system can achieve a speed of 12,000 bottles per hour when using a 1-liter bottle size. Shifting our focus, let's examine sachet and pouch systems. These packages use a coextruded film with multiple layers. From the outside to the inside, a typical structure includes an outer layer of PP, followed by a layer of PP with calcium carbonate, then a layer of EVOH, then PP with carbon black, and an inner layer of LLDPE. The pouch is formed by cutting the film to size, creating a bottom seal, filling the pouch, and then making the top seal. The machine that performs this is called a form-fill-seal machine. It is designed for free-flowing products and can be controlled electro-pneumatically, mechanically, or with a combination of both. It operates automatically and is commonly used for packaging products like market milk, curd, and lassi. The principle of an aseptic form-fill-seal system, like the Tetra Pak system, involves several stages. A roll of laminated film is fed through drying rolls and a hydrogen peroxide bath for sterilization using sterile hot air and radiant heating. The film is then formed into a tube and vertically sealed. Product filling occurs, and sealing jaws create the individual packets, with the process involving folding over and sealing flaps, sometimes with the application of a thin plastic strip. This is often a monoblock equipment setup. The operation of such a machine is continuous. It forms a tube from the rolled packaging material. Filling and sealing happen simultaneously. The film moves forward to form the next package, and the filled packet is separated while the next one is being filled. This creates a highly efficient packaging line. The formation of a sachet is a precise process, as illustrated by systems like the GSP-AK. Furthermore, specific machines like the EL4 Aseptic Filling Machine and the ES4 Straw Applicator work together to provide a complete, lightweight packaging solution. Now let's discuss our final category, carton systems. These cartons have a complex layered structure. From the outside in, the layers are polyethylene, paper, cardboard, another layer of polyethylene, aluminum, and a final inner layer of polyethylene. Each layer has a specific role. The polyethylene layers act as a moisture barrier and for sealing. The paper and cardboard provide stability and strength for printing. The critical aluminum layer acts as a barrier against oxygen, light, and flavor loss, ensuring the product inside stays fresh. Tetra Pak aseptic cartons are a classic example of this technology. The layers in order are 1. Polyethylene for moisture protection. 2. Paper for stability and strength. 3. Polyethylene for adhesion. 4. Aluminum as a barrier to oxygen, flavor, and light. 5. Another layer of polyethylene for adhesion. And 6. Polyethylene that seals in the liquid. These cartons can be formed into various shapes. Common shapes include the cup type, the square box, the tetrahedron, which is a pyramid shape, another square box style called the brick, and the gable top carton. Seals and closures are vital in aseptic systems. The machine must be capable of closing the package hermetically to maintain sterility during handling and distribution. In a form-fill seal machine, sealing is achieved using sterile hot air and pressure. There are different types of seals, such as the transversal seal and the longitudinal seal. Cartons are formed from a continuous strip of laminated material fed from a reel. The process involves forming the carton, often with a plastic reinforcing strip added. The product enters the carton, and a longitudinal heat sealer creates the main seam. A stainless steel float inside the carton helps maintain the liquid level, operating a product valve. Seals are made below the liquid level to ensure a full pack, and transverse sealing jaws close the top and bottom of each carton. This is a diagrammatic representation of one method for forming cartons from a continuous strip. Finally, let's look at the principle of a typical aseptic carton system. The process creates a sterile zone. It involves several stages: carton forming and erection, sterilization with hydrogen peroxide vapor and steam, followed by drying with hot and cold air. The sterile carton then moves to the aseptic filling station, which is supplied by an aseptic tank, and finally, the carton is sealed shut. Thank you for joining this detailed exploration of packaging machines. We have covered the key systems for cups, bottles, sachets, pouches, and cartons, along with their manufacturing processes and machine principles. This knowledge is fundamental for anyone in dairy technology. We hope this session was informative.